This is topic 14, stoichiometry calculations, video D, percent yield calculations, and we are working on question 3. We are given the question CH4 plus HBr yields CH3Br plus H2, or in other words, methane plus hydrobromic acid yields methyl bromide plus hydrogen. However, this question is asking if 13 grams of methane reacts with 21 grams of hydrobromic acid and the reaction proceeds with a 78% yield, how much methyl bromide is made? Before jumping into solving the solution, let's first break down the steps. First, what is the question asking? If we look back, it asks how much methyl bromide is made. Or in other words, we are asked to find the mass of methyl bromide. The question gives us the mass of the two reactants in a chemical equation. For the chemical equation, it is always best to make sure it is balanced, even if it is given to you. And also we are given the mass of methane, 13 grams, and hydrobromic acid, 21 grams. For these two, we must convert each of the mass of methane and hydrobromic acid to moles. This will determine which one is a limiting reagent. From the limiting reagent, we must find the theoretical yield. And then lastly, we find the actual yield, which will determine how much methyl bromide was made. In our first cell, we have the mass of methane, 13 grams. In order to convert 13 grams into its respective amount of moles, we have to use the equation mass over molar mass equals moles. Since we're given 13 grams is already our mass, we have to find the molecular weight of methane. The molecular weight of methane is 1 carbon plus 4 times the weight of hydrogen. And this gives us 12 plus 4 times 1.008. Therefore, mass over molar mass is 13 all over 12 plus 4 times 1.008, and this gives us 0.81 moles. And so the ratio of methane to methyl bromide is just 1. We also assume the amount of moles of methyl bromide is also 0.81. However, we cannot determine this is the limiting reagent because we still haven't found out the moles of hydrobromic acid. Therefore, we must continue converting the grams of hydrobromic acid to moles also. In our second cell, we have the mass of hydrobromic acid, 21 grams. And like what we did in our first cell, we must also convert the grams of hydrobromic acid to its respective amount of moles by using the equation mass over molar mass equals moles. The molar mass of hydrobromic acid is 1.008 plus 79.904, which is 1 hydrogen plus 1 bromine. Therefore, mass over molar mass is 21 all over 1.008 plus 79.904, which gives us 0.26 moles. And since the ratio between hydrobromic acid and methyl bromide is also 1 to 1, we can also assume the possible amount of moles for methyl bromide is also 0.26. Since 0.26 moles is less than 0.81 moles, we can assume hydrobromic acid was a limiting reagent and methyl bromide has 0.26 moles. Even though we found the amount of moles for methyl bromide, we still have not finished answering the question. The question had asked us to find the amount of mass of methyl bromide at the end. To find the amount of mass, we must use the equation mass equals moles times molar mass. And since we have the amount of moles, we just have to find the molecular weight of methyl bromide. To find the molecular weight of methyl bromide, we do 1 carbon plus 3 times the amount of hydrogen plus 1 bromine. This gives us 12 plus 3 times 1.008 plus 79.904. Therefore, moles times molar mass is 0.26 times parentheses, 12 plus 3 times 1.008 plus 79.904, end parentheses. And this gives us 24.68 grams. However, we are still not finished with the questions because what we found was only the theoretical weight of methyl bromide. What we want to find is the actual weight of methyl bromide. In order to do this, we must utilize the equation percent yield equals actual weight over theoretical weight times 100. But since we know percent yield and we know theoretical weight, we can move the equation around so that actual weight equals theoretical weight times percent yield. And therefore, theoretical weight is 24.68 grams. Percent yield was 0.78, and therefore we do 24.68 times 0.78, and this gives us 19.25 grams. And this is the actual weight of methyl bromide.